So after a few more tweaks on the Axiom solver, we end up with something that looks like this. Now, one major difference I did is I added 2 substeps, and if we go to our sourcing or simulation that is, we have a time scale of 2. I want this effect to come and go fairly quickly because if we go back to our reference here, this smoke isn't emitting for a very long time. It's a lot of smoke, but it kind of just emits in a fairly short amount of time and then it stops emitting. So for that reason, I set the time scale here to 2, and yeah, we end up with something like this. We might have to change this in the future. It's all just kind of a first draft here, but for right now, this is looking like a pretty interesting source for the density. So one more thing to complement this would be a collision with the ground itself. And how do you do that with Pyro? I made a quick tip a while back called, quick tips for volume collisions, where we use a static object to do this. However, that's not as ideal as creating collision volumes. And just in case you're not used to this workflow yet, all you do is you need to take whatever object you're trying to make a collision volume with, you use VDB from polygons, set that to a distance VDB called collision, and then you also need to create another volume that dictates the direction of the normal. So let's go ahead and say that we need a normal attribute on our box, and then on the VDB from polygons, we can just add in that attribute value. And this is going to be called collision vel, like so. If we go back to the fields that we need, collision vel. So those two come together like so. Let's turn the resolution to 0.05 real quick. If we source that into the Axiom solver, we will end up with this. And as we can see, we now have success. Do keep in mind that if this is just cutting off the density and you don't see the smoke bouncing off of the object, that you don't have collision velocity. That velocity is what's pushing this stuff downwards right now. So just keep that in mind. If it hits something and it just stops or the smoke dies, it's because it's not reading velocity properly. But this will give you an idea of what we're trying to achieve with the collisions on the terrain. And this is good for the sourcing. It's good for our main Pyro simulation. I just want to be sure that you guys have seen this sort of thing before. So that means back to our Axiom solver situation, we can just take our ground plane that we used up here for colliding against the particles, make a copy of that, and simply do the same thing. VDB from polygons. We'll go right here. You don't need a super high resolution for this, so 0.1 should be just fine. Let's call this collision. And also, we need some normals. So set down a normal SOP right there. And just like you saw before, go to vertex normal. And call this our collision vel, like so. Don't worry about this setting. This is just fine for right now. Once we have that, we should merge that with this guy so that basically we have all of our source volumes coming in like so. And after doing all that, we end up with this. So not looking too bad as far as a source goes. From here, if we create a VDB activate and we set this to, ironically, deactivate, that will get rid of any areas that are not necessary for representing density. And actually, while we're at this, let's also delete any other field besides density. So delete non-selected on that. We only have density. We also don't need those extra attributes that were coming along with it. So delete everything except for name, because that's the name of the field, right? So we only have density, 2 million voxels. That is still about 2 million. Sometimes this cleans up the memory a little bit more though. And then also we can use a VDB resample, or yeah, VDB resample, and set that to using voxel size only. So now we can set this to 0.1, and if we middle mouse, we're at about 300,000. We can go a bit less than this actually, maybe 0.075. And like I've said before in previous tutorials, we want to stay around 300 to 400,000 voxels roughly. So maybe 8.5. Actually more like 300 to 500,000. So yeah, this is fine right here, 437,000 voxels. And this will become the basis for our density. One thing I'd like to add to this whole section right here is the fact that this only works well in production if you can be fast about the whole thing. Because taking all of this time to create a high quality source, it's really, really important because the source makes the biggest difference on the quality of the simulation, but you don't want to spend too much time on it. So, in my opinion, using the Axiom solver gives you a really fast iteration time on that source, which makes it great for just giving you a density field, trying to mess around with all the microsolvers. That adds a lot of detail to the source. And from here, we can just do all the normal methods for sourcing into a pyro solver. So we can add extra noise, we can multiply our density volume by whatever we'd like. And with that density now set, the next step is going to be in combustion. I kind of think of this as taking the density, giving ourselves a cloud to work with, and then moving that cloud around with combustion and eventually with various debris flying through it to give us those spikes. So that's the general idea of how we're trying to go about this. We still need to add in color. However, for right now, I'd like to move on to combustion. We can come back around towards the end of this course, adding color. It's not a huge deal. But for right now, I just want to come back to that later and move on to combustion.